Hello, this will be a demonstration of Proposition 8 from Book 3 of Euclid's Elements, which states that if a point be taken outside a circle, and from this point straight lines be drawn through the circle, one through the center and the others not, then of these straight lines on the concave arc, that through the center is greatest, and that nearer to it will always be greater than that which is more remote. And of these straight lines on the convex arc, that which is between the point and the diameter is least, and that which is nearer to it will always be less than that which is more remote. And only two equal straight lines will fall from this point to the circle. This is very similar to the previous proposition. We begin by simply having the circle ABC, like so. We have the point D outside of it. And then from D, we have straight lines actually falling through this center. And so we have DGA, which goes through the center. DGA goes through the center. We have another straight line like this, and this we shall call DKE. We have another straight line falling like this. We shall call this straight line, DLF. And then we have another straight line falling through the circle like this. And we shall call this DHC. And on the arc AEFC, an arc simply being a portion of the whole circumference, on the arc AEFC, this concave arc right here, we shall find that DA is greater than DE, which is greater than DF, which is greater than DC. And considering the convex arc HLKG, we shall find that DG, which is the straight line between the point and the diameter, GA has to be a diameter because it goes through the center, we shall find that DG is less than DK, which is less than DL, which is less than DH. And finally, from point D, we shall only find two equal straight lines that also fall on the circle ABC. First order of business, find the center of the circle. We shall call this point M. We can do this by proposition 3.1. Then we shall join plenty of straight lines. We shall join ME, MF, MC, MK, ML, and MH, like that. We can join all these straight lines by postulate 1, of course. Now we know that AM and EM have to be equal. AM and EM have to be equal by definition 115, the radii of the same circle. So we can add equals to equals, namely we shall add the straight line MD to both. And so we can say that that AM plus MD, that is the straight line AD. So if we add AM to MD, we get the whole straight line AM like that, or AD like that. We can say that AD is also equal to EM plus MD. This is common notion too, adding equals to equals. We also know by proposition 120 that if two sides of a triangle be added together, they will be greater than the remaining side. And so we can say that in the triangle EMD, we know that EM plus MD must be greater than the remaining side ED. And so by a property of magnitudes, we can substitute EM plus MD for what it's equal to, so that we can say that DA is greater than DE. Now, we also know that ME is equal to MF, again by definition 115. We also know by common notion 5 that the angle FMD is a part of the angle EMD, and so we can say that the angle EMD is greater than the angle FMD. And if in two triangles, two sides be equal to two sides, and the angle contained by the equal sides be greater than the other, then the base of the one triangle will be greater than the base of the other. And so we can say that ED, which subtends the angle EMD, will be greater than FD, which subtends the angle FMD. And so combining these two inequalities together by a property of magnitudes, we can say that dA is greater than dE, which is greater than dF. Similarly, we can prove that FD is greater than CD. So combining all of these inequalities together, again by a property of magnitudes, we can say that dA is greater than dE, which is greater than dF, which is greater than dC. This is the first part of our specification done. Now, by proposition 120, again, we can say that in the triangle MKD, the straight line MK plus the straight line KD must be greater than the remaining straight line MD. This is again proposition 120. We also know that MK is equal to MG, again by definition 115. Ooh. And so we can say adding equals to, oh, what the hell's going on here? Sorry, my bad, there's noise going on outside. Excuse me. Oh, subtracting equals from equals. That's what's going on here. My bad. We can subtract MK from both sides, or we can subtract MK from one side and MG from the other because these two are equal. By common notion 3, we can subtract equals from equals, so that we can say that MK plus KD minus MK, which just leaves us with the straight line KD, is greater than MD minus MG, which is just the straight line GD, right? So if we have the straight line MD like this, if we subtract MG from it, we're left with the remainder GD. And so we can say that KD is greater than GD, and flipping this inequality around, we can say equivalently that DG is less than DK. Now, by proposition 121, we can say that MK plus KD is less than ML plus LD. So let's look at that. MK plus KD. There it is. So we're dealing with the triangle as MLD and MKD. And MKD being inside of the larger triangle MLG, we can leverage this proposition 121 and say that MK plus KD is less than ML plus LD. And again, we know that MK is equal to ML. We know this by definition 115. So again, subtracting equals from equals, we can say that KD is less than LD. Excuse me again. Not a smooth demonstration. So again, combining all of these inequalities together by a property of magnitudes, we can say that DG is less than DK, which is less than DL. Similarly, again, using proposition 121, we can say that DL is less than DH. And again, by a property of magnitudes, combining all these inequalities together, we can say that DG is less than DK, which is less than DL, which is less than DH. Now, this is the second part of our specification done. Now, finally, on the straight line MD, we shall construct the angle DMB such that it is equal to the angle KMD. KMD like this. And so on MD, we make, I'm going to try and make this look about equal. That's not good. Oh, that's beautiful. We shall make the angle DMB right here, such that it is equal to the angle KMD. And then by postulate, we knew that by proposition 123. And then by postulate 1, we shall join the straight line DB. Now we know that MK is equal to MB because they're both radii of the same circle. That's definition 115 again. We also know that the angle KMD is equal to the angle BMD. We know this by the previous step. We made BMD such that it is equal to KMD. And so using 1,4, because we have one side equal to one side, MK equal to MB, we also have, what do we have? We have the straight line MD, which is common, and we have the angles contained by the equal sides also equal, we can leverage Prop 1-4 to say that the two triangles KMD and BMD are equal in all respects, and namely that the straight line DK, like so, is equal to the straight line DB. Now, I say that from point D, there cannot be constructed another straight line equal to DK falling upon the circle ABC. For if this is the case, let's create such a straight line, like so, and we'll call it DN. Now, we know that DK is equal to DN because we made DN such that it is equal to DK. We also have just proven that DK is equal to DB. And so by common notion 1, we can say that DN and DB are equal to each other. Now we know that DN is equal to DB, but we also know that because on a convex arc, DN is more remote from DG than DB is, DN must also be greater than DB. And so we have arrived at the fact that DN must be simultaneously equal to and less than, or DN must be simultaneously, the lights turned off. There we go. Figured that happened eventually. We arrive at the fact that DN must be simultaneously equal to and greater than DB, which is absurd. And so we can say that another straight line equal to DK falling from point F onto the circle ABC cannot exist, and that only two equal straight lines can fall from point F to ABC. This being the final thing that we have set out to prove. We are done with the proposition, therefore, etc. QED. Now, again, I have nothing to say about this proposition, so I shall simply move on to 3.9.